Hi everyone, this is lesson 20, composite area problems. Our essential question is how can we set up and solve complex area problems? Okay, once you write down your essential question, we're actually skipping example 1 and exercise 1. I'd like for you to turn to page 154. Okay, example 2 says to find the area of the figure that consists of a rectangle with a semicircle on top. Use 3.14 for pi. Okay, first of all, I want you to write a question in the margin that says, what shapes do we see? So when it comes to these complex area problems, we first need to identify what shapes we see. Then we're going to answer the question, what are the formulas? So before we do any math on our calculator, before we try to solve any numbers, we need to identify the shapes and then the formulas that are going to be used. The biggest problem that I see is that kids take numbers and they just multiply them. They just go, oh, 4 and 7.5. I guess I can get the answer from there. Well, a lot of times they're literally called complex shapes. So we're going to have to do a little bit more than just multiply those two numbers together. So first of all, pause it and write down what shapes you think you see there. Okay, I can see half of a circle, and you can just write half circle. And the other shape, be careful saying square. I know that a lot of kids think square when they see that, but we don't know for sure if it's a square. We do know that it is a rectangle. It might end up being a square if all the sides are the same. Okay, so for half a circle and a rectangle, what are the formulas? Well, it says area, by the way, so circle that. And it even says a rectangle and a semicircle. So sometimes it'll tell you the shape and sometimes you'll have to figure it out. So for this one, we're going to use the circle formula for area, and then it's half of that. So if we're going to do half circle, it would be pi r squared, but we only want half of that. So once we find the area of the circle, we're going to take half. And then the rectangle is going to be base times height or length times width. I'm putting those two things together, so we're going to put a plus sign in between them. This is the most important part when it comes to solving complex figures, identifying the shapes and coming up with formulas. Once we do that, now we can figure out what numbers get plugged into it, which is definitely not just going to be multiplying two numbers together. Now, for the circle, it's a little tricky. We're going to have to pay attention. They always give you enough information, so don't be thinking like, well, they don't tell me this or they don't tell me that. I promise you, it's possible to figure out the radius, the base, and the height just from what they gave us, and I'm here to help you go through this step by step. So we have 1/2. For pi, we're going to use 3.14. The radius is the one that we're going to have to figure out. So you go ahead and try to figure out if this circle kept going, could you figure out just the radius? And hopefully you can see that this is 4 meters. So this line is also 4 meters. Okay, 4 meters, 4 meters. That would make the radius not 4, it would make the radius 2. It would make the radius 2. Okay, so then we can plug in 2 squared. Okay, plus the base and the height. Well, I know that one of the lengths is 4 because if we're talking about, I'll outline this in green so you can see it. If we're talking about this rectangle, then I can see that one of the sides is 4, but I don't know what the height is. It's not 7.5, so we've got to be very, very careful. I'm going to erase this and clean it up so that we can kind of figure out if we know that this whole thing is 7.5, what we're really looking for is just this length, which would be the height of the rectangle. It's not 7.5. We need to figure out what it is. And if the only other piece of information they give us is the 4 meters, then that's got to be able to help us. And here's why. We just figured out that the radius was 2. If the radius is 2, from the center to the edge of the circle in any direction, it would be 2. So that means that this line right here is 2 meters, which means that this piece is 2 meters. So what we can do is we can subtract 2 from 7.5. This would have to be 5.5. Okay, and again, I'm going to clean it up so that you can see. The reason it's 5.5 is because this line plus this line has to equal 7.5. And we know that this piece is 2. That means this piece has to be 5.5. So just a quick visual. You can go back and watch it again to see why it's 5.5. But we're going to plug that in as our height. And now all we do is solve. So this should be the easy part. Get this number, and then we're going to add them together. Okay, go ahead, pause it, and calculate what the area of the half circle is, and then the area of the rectangle, and we're going to add those two numbers together. Okay, did you get 6.28 for the half circle and 22 for the rectangle? Again, you can pause it and add those two together. 28.28 meters squared. And we're going to put approximately. Once we use 3.14 and not the pi symbol, it's all approximated. So it's very, very close to 28.28 meters squared. Okay, for exercise 2, go ahead and pause it and answer the two questions that we just talked about. So what shapes do we see? And then what formulas are we going to use? Go ahead, pause it, and write those two things down, and then see how you did. Okay, what shapes do you see here? Did you write triangle plus half a circle? Again, this is area because it says find the area of the shaded region. Okay, so a triangle is 1/2 base times height. You can add that to your list of formulas if you forgot what the area of a triangle is. That's something that you've learned in the past. Okay, and then half circle would be half pi r squared, since pi r squared is the area of a circle. Okay, let's go ahead and figure out what the base and height are of all these things. If you notice that the radius is 4, you can plug that in on the circle part, so 3.14 times 4 squared, and then of course it's only half of that because it's half a circle. Now for the triangle, base and height meet at the right. In fact, I want you to write that off to the side here and put it in quotes so you know it's like a little sing-song. Base and height meet at the right. That means anytime you see base times height in a problem, you know that it needs to be at a right angle. And the reason that's so important is because we need 14, but we also need this side because that's where the right angle is. Those two lines are what make the right angle. If you notice, this would be the same as the diameter of the circle. And if we know the radius, we know the diameter, so that would be 8. Okay, so for our triangle, we have 14 times 8 for our base and height. Okay, go ahead and pause it and calculate it. This is the part that you should be really good at right now. It's important that you always show your work going down because this is the triangle right here, and this is the half circle right here. And you can see that going down. Okay, did you get 56 for the triangle and 25.12 for the half circle? That would be a total of 81.12 centimeters squared. And it's okay, of course, if you get something a little different because these are approximated since we used 3.14 for pi. Okay, this is a nice short video. I just wanted to do 2 examples with you, and then you'll be able to get started on your lesson 20 independent practice.